Hello class, in this video I'll be showing you an application of the exponential growth and decay function. Let's begin. Recall that the exponential growth and decay function is p of t is equal to p naught times e raised to the kt power. P of t is the total population after t years, k is the relative growth rate expressed as a decimal, P naught, or P of 0, is the initial population, and T is time in years. So now let's take a look at an application of the exponential growth and decay function. The population of the good place grew from 8,500 to 13,000 in 5 years. Assuming uninhibited exponential growth, what is the expected population in an additional 3 years? Round your answer to the nearest whole number. I'll start by identifying some of the quantities in the problem. P of 0 is equal to 8,500, and P of 5 is equal to 13,000. We also have T is equal to 5. So what we're missing is the relative growth rate, K. So the first thing I'm going to do is we're going to solve for K. So we have P of t has to equal 8,500 e raised to the k times t power. And the reason why 8,500 is the coefficient is because that is the initial population of the good place. We know that P of 5 has to equal 13,000. So this has to equal 8,500 e times k times 5. Now to solve for k, we need to isolate the e raised to the 5k factor. So I'm going to do that by dividing both sides of the equation by 8,500. Next, I'm going to apply the logarithmic property of equality. And finally, I'm going to apply the power rule to convert the exponent to a factor. The natural log of e is equal to 1. So to solve for k, I'm going to divide both sides of the equation by 5. So we have k is equal to the natural log of 130 divided by 85, all divided by 5. Now I'm going to use Decimus to find an approximate value for k. So I've gone ahead and entered k into Decimus. And k is equal to 0.0925247043,896. And with this problem, I am not going to round the value of k. I'm going to leave k as this entire decimal. So what I've done in Decimus is I set k equal to this expression. And I'm going to come back to this in a little bit. So now that we have the value of k, we can go ahead and solve the problem. So we have P of t is equal to 8,500 e to the kt power. We want to know the population in an additional 3 years. So an additional 3 years from 5 years will be 8. So P of 8 is equal to 8,500 e to the 8k power. I'm going to use Decimus to evaluate this expression. I've gone ahead and entered the function into Decimus. You will notice that I used x in place of t, and I did not enter the decimal approximation in for k. Decimus knows that k is equal to this decimal representation because I set k equal to it in the line above. What I'll do now is show you that this equation is correct by evaluating this expression for when t is equal to 0, and notice you get 8,500. Next, I'll evaluate this expression for when t is equal to 5, and we get 13,500. And finally, I will evaluate this expression when t is equal to 8. And this number rounded up is 17,819. So the total population in an additional 3 years is 17,819. And we are done.